Good evening, everyone, and welcome to this penultimate session in the second day of SURATi TechTalks 2022. Once again, it is a talk by our favorite speaker, Nilesh Gule, and he is going to deliver again lectures on monitoring and observability of Kubernetes with OSS tools. OSS here stands for open source systems. So in this session, we will be exploring different tools from open source ecosystem, which can help greatly to improve the monitoring and observability features of Kubernetes. We will be also exploring the log aggregation using Elasticsearch from Prometheus and Grafana for metrics and Sentry for exception handling. So yesterday I had already introduced you all to Nilesh Gule, who is passionate about software with a motto of code with passion and strive with excellence. So today I will not be wasting much of the attendees' time explaining more about his profile. But as already we are a bit late in this session, I would hand over the control to Nilesh. Nilesh, please take over and start your presentation.
Thanks, Nilesh. Let me go over again, who am I? I think we covered this yesterday, and some of you also connected me with me offline. And I also mentioned that we have the Azure Singapore user group, and in case you want to see the sessions past ones, you can hit that bit.ly link. Let's quickly get to today's session, and let's see what do we need as a prerequisite for today's session. So today we'll be talking about how to improve the monitoring and observability for Kubernetes. So just like yesterday, we have some prerequisites in the form of Docker. People need to know a bit of Docker and obviously Kubernetes to understand how containers work, how self-healing works, how service discovery works, how scaling works in Kubernetes. And then there is also a bit of understanding required for cloud native applications. So you might have heard about this 12-factor apps or 12 factors, which are quite commonly used while building cloud native applications. And some of them are that it is a scalable environment where your applications, they can scale in a dynamic environment. It could be deployed onto let's say public cloud, it can be deployed on private cloud, or you could have a combination of public and private cloud, which is hybrid cloud. These are also exemplified by containers, then service meshes, which are used for the service to service communication within a cluster. Microservices are becoming quite popular nowadays. And obviously with that, a lot of automation is coming in the form of infrastructure as code. So we have things like Terraform, which enable us to build immutable infrastructure. So even the infrastructure that we use for our deploying our applications can be stored as a piece of code, and we can have it just like regular code that we have. This can be stored in a Git repository or source control, and we can have those best practices followed. And APIs are becoming, again, very popular nowadays. We hear, as I mentioned yesterday's call, a lot of things around event-driven programming and event-driven architectures. People are moving from batch-based systems to more and more real-time systems, and API integration is one of the most in-demand skill nowadays. Cloud-native applications are also loosely coupled, and these are resilient. They are highly observable and manageable. As we move away from, let's say, maintaining systems or infrastructure, our own data centers, as we start moving to public cloud or hybrid cloud, our control over the infrastructure becomes less. So we have to build systems which are more resilient to failures, unlike older days where we could expect like 100% of availability. Nowadays, you can expect AWS or Azure, a particular region, to go down for some time, and our systems has to be able to cope up with that, both from application as well as data point of view. And with this, we also have to build a lot of observable features into the applications. So we will see some of these things in today's talk, how we can make our systems more observable and how we can monitor them in a cloud native environment. So I'll focus more around Kubernetes in this session, but cloud native applications can also be deployed outside of Kubernetes as a container environment or container orchestration. So this particular iceberg shows different layers of the things which are required when you start building and deploying applications on Kubernetes. In today's list of sessions, I saw that there was a session earlier on Docker, how to get started with Docker. Then just before this, there was a session on using SQL Server 2019 with Docker. And following my session, there is a session on microservices. So I hope what I'm going to talk today would make sense about all these other topics, which are quite interrelated to one another. So if you attended the Docker session, you might understand that it is quite easy to start building Docker images and creating pods, creating deployments, which are like basic units of deployment in Kubernetes. Then we can also go a step further and we can have things like secrets, which are a way of managing. Can you hear me? I hear a bit of noise in and then we also have things like ingress, config map, and services. But as you go down this stack or down these layers, things start to get interesting and complexity increases. So if you have to work with data, if you have to work with stateful applications, then you have to work with things like stateful sets. You will be working with persistent volumes. Then resource limits comes into the picture. If you want to increase the availability of your system, then you would be obviously talking about load balancing, things like replicas. I think someone needs to mute Tejas. Hello? Yeah, thank you. And as you go down this track, the complexity of each and every layer or each and every feature keeps on increasing, and it becomes quite complex. That is where you tend to hear people saying that it's easy to get started with Kubernetes, but it is quite difficult to maintain things in production and to put systems in production on Kubernetes and to maintain them. It is really tricky thing. You need to have a lot of skills, and there's a quite in demand. So with that regards, I would say that a Cloud Native Foundation or CNCF has done a very good job in terms of coming up with something called as the Cloud Trail. This is a set of projects which the CNCF maintains, and these are mostly open source projects. They categorize them into different sections or categories like containerization, CI/CD, orchestration, then observability, and so on and so forth. And they try to give guidance and recommendations in terms of which are the projects which fall under these different categories. And if you're building cloud native applications, you can refer to these projects. These projects are in different stages. Some are already graduated, and some are incubating, some are in initial stages. So they are like sandbox projects. But you can look at different projects, you can follow these projects, and based on your needs, you can adopt these projects in your applications. So as part of this, today I'll be covering a couple of projects here. One is Prometheus, the other one is FluentD. Elastic is not mentioned as part of CNCF, but it is quite popular. It's not only for cloud native application. Elasticsearch has been there for quite a long time, and it is one of the commonly used tool for log aggregation. So I would recommend that if you want to learn more about these projects, you can refer to this link here. There is a lot of documentation available from each of these projects. So let's turn our focus towards today's topic in terms of monitoring and observability. Why do we need these things? So let's first start with log aggregation or aggregated logging. Or centralized logging. Why do we need centralized logging? If you look at the history of cloud adoption or the way cloud is being used by different organizations, there is a drastic increase in the way people are moving applications to cloud. Initially, it started off with infrastructure as a service where you just had a VM somewhere in cloud and you deployed your application. Then cloud providers realized that they can provide value-added services on top of VMs. So they came up with a platform as a service. So you have PaaS services, and now you have so many things as a service. You have database as a service. You have Kubernetes, for example, container orchestration as a service. There is serverless, and we don't really know where these services are running, or we don't have so much control over the underlying VMs or the infrastructure. As we move away from infrastructure as a service to platform as a service, and then over to serverless, our control gets less and less. We only get access to things like logs. So that is why we need centralized logging. If we look specifically at container-based workloads, there are like application-specific things. Let's say you are a banking organization, or you are in certain industry where for compliance reasons, you have to have a long-term retention of your logs. Usually 7 years or 10 years logs are required to be preserved. If we are using Kubernetes default settings, then based on what the administrator has configured, the logs are rotated on regular basis, and we don't have long-term retention of logs. There could be workloads which are running on different nodes. So the way Kubernetes works is we just give in a declarative manner our requirement for deploying a particular workload. And let's say there are 10 nodes in the cluster. Based on the resource availability and various other factors, Kubernetes scheduler will decide where to schedule that workload. Let's say something goes wrong with your application and your workload was running on node 1. When it restarts, Kubernetes will be able to restart that workload based on, again, some of the configurations that you do. Now this workload might be running on a totally different node. It might be running on node 10. So if you are storing logs locally on that node, then you would lose those previous logs in such scenario. Yesterday, I showed how auto scaling works. Again, in that scenario, what I demonstrated was the pods were created dynamically. And then when the workloads were reduced, those pods were deleted. In such cases, again, we don't know exactly where those workloads are scheduled, and they can be dynamically running in any place. So that is one of the core area, I would say. The other one is the infrastructure itself. If we are using, let's say, a managed Kubernetes environment like Azure Kubernetes Service, and if we do a Kubernetes upgrade, currently maybe my cluster is running on 1.20 version, and I want to upgrade to the latest version, let's say 1.23. In this case, the Azure team, or the way this upgrade works is they're not going to upgrade your existing nodes. They create new set of nodes and they replace the old nodes. So the 1.23 version, or whatever version you are trying to run, would be created on a different set of nodes, and those would replace the existing nodes. So again, in this scenario, if you are storing your logs on the local nodes, those would be one. This can also happen when the scaling happens. So let's say if you're not upgrading your cluster, but you have enabled auto scaling. So based on the workloads, the cluster nodes might be added and deleted to your existing cluster itself. In such scenario also, you might lose the logs if they are stored locally. Then coming to PaaS and serverless services, we don't have any control on the underlying infra, or we don't have much control, I would say. We just are asked in terms of like what is our requirement, whether we are going to deploy a .NET application, Java, Node, or Python application, and the cloud provider takes care of provisioning. Maybe it's running on Windows VMs or on Linux VMs. It could be running on a container somewhere. We don't know exactly. And the way this happens is, in such cases, we might be using the cloud provided logging services like Azure Monitor or Azure Log Analytics in case of Microsoft Azure, or CloudWatch, for example, in case of AWS. So what I'm trying to say here is, in all these kind of scenarios, we don't really have control over the logs. And we definitely need, from an application maintenance point of view or debugging point of view, and even for the application support, production support, access to the logs. So that is where Elasticsearch is quite popular, both with on-premise kind of workloads as well as in cloud, traditional applications as well as cloud native applications. So what I'm going to demonstrate today is how we can use what is called as a EFK stack. E stands for Elasticsearch, F for Fluent Bit, and K for Kibana. These three different projects or these three different tools, they work hand in hand. You might have seen in some earlier talks, people talk about ELK. So instead of FluentBit, the Logstash was a previous agent which was used. That was quite popular, I would say 5 years back. But in today's cloud native environments, FluentBit has taken over, and it is really optimized for cloud native kind of workloads. So the way this is going to work is we will install FluentBit as a log collector or log aggregator on our Azure Kubernetes cluster. All this will be deployed as Docker containers, and I will be using Helm to deploy each of these projects or each of these components. So once FluentBit is installed, following the 12-factor app methodology, my containers or my application is going to write logs as a stream of events. It is not going to store logs anywhere in a file or in a database. It's going to write it to a standard output, which will be then collected by FluentBit. It will aggregate the logs, and at certain interval, it will write this log data to Elasticsearch, which acts as a storage. So the long-term storage of logs is provided by Elasticsearch, which has its own way of storing data, which is optimized for search. And then we have Kibana, which is used for searching of the logs, visualization, and building of the dashboards. So I'll use the same example that I showed yesterday, which is the TechTalks demo, which has a RabbitMQ producer service and RabbitMQ consumer, and this will be writing some of these messages into a RabbitMQ queue. So let me switch to the demo mode and let's see this in action. So I have Octant, which is the Kubernetes visualizer here, which shows me the state of the Kubernetes cluster. And I will go into the workloads, or let's go into the services, discovery and load balances. I have the TechTalks producer and the consumer service deployed here. So I can take the IP address, which is used to generate the workload. So I have the RabbitMQ producer, and it's the same IP as yesterday. I haven't made any changes. So I will use Postman to go and generate, let's say, we created 500 messages yesterday. Let's create 2,500 messages today. And this will start processing. Once the messages are produced on the RabbitMQ, the consumer will come and start processing these messages in a batch. Now, if I want to see the logs for those consumers, so let me switch to the workloads and see what are the pods running in the cluster. So we have various pods running for Elasticsearch, FluentBit as well, but I'm interested in the pods which are related to this RabbitMQ producer and consumer. So let's look at the producer first. If I want to see the logs, one way is if you have access to something like Octant, you can go into the pod and you can visualize the logs. The other way is usually the administrator or people who have access to the Kubernetes cluster using kubectl, they can use kubectl logs as a command line query, and they can find the logs for a service or for a particular deployment. So here we can see that the TechTalks producer is writing some logs, and it's saying I've published a message to the queue. So every message that gets published to the queue, there is a log being written. Now, this is okay, sort of okay, I would say, because I have access to the visual Octant. But if you don't have access to Octant, then searching for these kind of logs onto terminal, it is quite difficult. So that is where we would configure Elasticsearch to pull these logs and visualize them. So let me also show you quickly the logs for the consumer. Hopefully the consumer would have started. Yeah, we have 44 pods, so definitely the consumers have kicked in. So the consumers writes a log in a slightly different manner. Let's go into one of the consumer pod. and see what is it that is being written. So here it is writing like what is the tech talk ID, what is the category, what is the level of that talk, and it's also writing some things like when the message is received and things like that. So this is written for every message by the consumer which it is processing. So now we have the logs from both producer and the consumer being written to the log stream. Let's see how we can configure Elasticsearch to pull these logs. So as I said, I'm going to use the Helm chart, which is the package manager for deploying an application with all its dependencies onto a Kubernetes cluster. There is a Helm package for Elastic available. So I use the Helm package manager and I add the repo, Elastic repo, which is at helm.elastic.co. Then I update this repo so that I get the latest version of that onto my local computer. And then I install the Helm for a specific version of this chart. So these packages in Helm, they're called as charts. So I'm using 7.13 version of the chart of this Elastic, and there is an Elasticsearch project inside that or repository, and I'm naming it as Elasticsearch. Once the Elasticsearch is deployed, I also deploy Fluent. So the process is the same. I add the Fluent repository. I use the install command of Fluent, and I configure some things for the daemon set. So the Fluent can be configured as a deployment or a daemon set. Daemon set is like a system daemon. So every time something runs on a node or the node starts, this would be running as a daemon. So let's say tomorrow I add a new node to my cluster. Automatically, this daemon set will be configured to run on that particular node. I don't have to go and manually configure anything once the daemon set is created within the cluster. And finally, I go and deploy Kibana. So again, same way, from the from the Bitnami repository, I add the Kibana project. And I set some properties like what is the master for Elasticsearch and what is the Elasticsearch port that it is going to use. So when I deploy Elasticsearch at the first, right at the beginning of the script, it is going to use the default 9200 port, which I'm configuring here. And with this, we have the mechanism using which our logs can be collected by the Fluent bit. They can be stored to Kibana and we can visualize. So to visualize, let me go to the browser and let's go to the Kibana user interface. So this is the user interface which Kibana provides. And we can have different timelines based on which we can filter this or visualize these logs. So let me just set the refresh here, automatic refresh for every 5 seconds. And let's start. So now we can see that there are some logs here in this time period. I think I selected a wrong time period here. Let's also fix that. Last 15 minutes. Let's narrow down our search to last 15 minutes and let's refresh every 5 seconds automatically. So here we had 30 hits in last 15 minutes. On an index which is created from the Fluent bit, which is called as Cube 2022. So this will log both the application logs as well as the infrastructure logs. And we can find out a lot of information from that, like the timestamp, what is the type of the log. It will have these labels coming from Kubernetes and all the information like the host ID. So I can define a pattern in the settings of that Fluent bit, how my log should be written to Elastic, and that log will be then automatically populated here. So let's say I know that my producer or the consumer in this case has a text string which says TechTalks persisted successfully, and I want to search for this. Sorry about this. This is the demo effect. So usually during the demo, you see that all of a sudden it becomes slow. So what I was expecting was that it should have shown quickly the results that the TechTalks was persisted. It should have filtered out of these 33,920 hits in the last 15-20 minutes, only those which contain this text. So if I will give it one more try to see if it works. Come on. This is still showing the old data. Looks like there is some problem with, okay. No, I think it got here. Yeah, so we can see that it is now showing only those messages or the log entries which contain this message as TechTalks persisted successfully. So imagine you are a business user or you are a developer who doesn't have access to the Kubernetes infrastructure, but you still want to understand how your application is behaving, or you are an application support engineer. This could be a very good way of giving access to the people who don't really need access to Kubernetes, but they still need to understand and work with the application monitoring. So that was for the logging part. So all that I had to do was to install this ELK stack or EFK stack on my Kubernetes cluster. No change required on my application code. Now let's go back and look at the next aspect, which is the monitoring. And like we did for the log aggregation, let's see why do we need monitoring and why do we need alerting. So same way, I will try to categorize this into 3 different ways. First one is for container-based workloads. We need to monitor things like the resource usage. Usually if people are coming from, let's say, traditional background and they don't know how to design applications for cloud native environments, they might still think in terms of the old ways, and they might provision infrastructure and resources like it was done in the past. You don't really need like 1 GB or 2 GB of resource for a pod. Your microservices, they are supposed to be very lightweight and they need to be working with minimal amount of resources. So at times it might happen that people request for resources which are higher than what they need. So obviously you need to monitor what was requested, what the application is using in the runtime environment, and if there are any outliers. Same thing for scaling, I would say. Let's say there is a need to scale the application and you need to monitor the metrics at the time of scaling to see whether the application is really meeting your scaling needs or not. If you go back to the Kubernetes level, Kubernetes itself has its own resources like the API servers, it has the controllers which are running. So we need to monitor that from a Kubernetes infrastructure point of view. And when it comes to PaaS services, similar thing. Since we don't have access to all the underlying infrastructure, we need to identify if there are any bottleneck, if there are any resource issues. So we need to monitor this. So in this case, Prometheus is very popular. It's one of the second project or one of the top 3 projects to be adopted by CNCF after Kubernetes. Kubernetes was the first one, and its popularity is growing day by day. So here I'm showing you the architecture of Prometheus. There are 4 main components, I would say. First one is the Prometheus server, which is basically a time series database. It uses a pull mechanism to pull matrix in a certain format. There are 3 or 4 different types of data types or types of matrix that Prometheus supports, like counters, histograms. These are some of the types of matrix supported by Prometheus. And then it can pull this data from different targets, services in Kubernetes, for example. If we are running Kubernetes jobs, then there is another way called as push gateway. But the recommended approach for Prometheus is to use this pull matrix. And it also uses things like service discovery in Kubernetes. Then the other component is alert manager. When something wrong happens in Prometheus, or if, let's say, some of the metrics that you are monitoring, if they are behaving not as per your expectation, you can alert using different integrations that Prometheus has. You can fire an email, you can use PagerDuty, you can have Slack integration, Microsoft Teams can be integrated. There are different targets to which this alert manager can connect. And it also has a web UI, which is called as the Prometheus web UI, where we can query the data that is stored inside Prometheus using a query language called as PromQL. This is somewhat similar to SQL, but it has some functions and things which are specific to Prometheus. So it's called PromQL. What we will be doing is we'll be installing Prometheus along with some of the other components, and then we will use Grafana, which is a visualization tool. Now, Grafana is like, it's very vast. It has data sources or support for multiple data sources. It can connect to various types of data, and it can give very visual or very intuitive graphs for analysis. So Prometheus is just one of the data source supported by Grafana, and we will be using that. So for this, I will use a slightly different application. I will use a Spring Boot application, which is called as a conference app. And this has things like list of sessions, speakers, and it is built in Java, Java Spring Boot. Spring Boot has very good native integration or very good support for Prometheus metrics. So let's see how we can first install Prometheus on our cluster, and then how we can use Prometheus. So for installing Prometheus, again, I have a small script, which is again based on Helm. So many of these projects, they support Helm-based deployments. And what happens in case of Prometheus is it creates something called as an operator. So think of a Kubernetes operator as a personal operator or a manual operator. What an operator does is it knows how a particular system has to work. And if something goes wrong, it knows how to fix that error. So same way, when we deploy Kubernetes related or Prometheus related objects, there are a set of prerequisites. There are things which needs to be set up in a particular order, and that is done by this operator. So I use again a Prometheus community repo or a Helm chart. There is a repository or a chart called as Cube Prometheus tag, which is a combination of this alert manager. Then it has Prometheus, it has Grafana, and it also has a set of visualizations or dashboards which are created specifically for Kubernetes kind of environment. And then I override some of the default values as part of this deployment, just for configuring this as per my requirement for my cluster. And then we can see what are the objects which are created. So Prometheus, once it is deployed in our cluster, it creates a certain amount of custom resources. So if I go back to the Octant, and if I look at the cluster view, and if I look at custom resource definitions, we will see some custom resources which are created here. And this is what helps us, the application teams, to integrate with Prometheus. So if this page can load quickly. Yeah. So whatever is here, ending with monitoring.coreos.com are the ones which are deployed by that Helm chart. And these are related to Prometheus. So we have the alert manager config, we have the alert manager, there is pod monitor, there are some probes, there is Prometheus monitoring, there are some rules. So all these objects, we can use them in our applications. So let me go to the Java application and show what is required on the application side so that we can integrate with Prometheus. So the first thing is I need to add some dependencies so that my application can publish the metrics in the format that Prometheus understands. So I need to add two dependencies. One is called the micrometer and the other one is called micrometer registry Prometheus. So if you have worked with Java or Spring Boot, you know that this is how you define the dependencies in a file called pom.xml. And then in our application configuration or application properties, we need to put some configuration specific to Prometheus. So I say that in the management endpoints, I want to expose an endpoint for Prometheus. And then for the Prometheus metrics, I specify some properties like I want to enable the metrics, the endpoint has to be enabled, and the metrics have to be exported in the Prometheus format. Once I do these two changes, adding the dependency in my POM file and configuring this 3 or 4 lines of code in the application configuration, my Java application or Spring Boot application would be able to publish metrics which are understood by Prometheus. So let's go and look at the data which is available in our Prometheus. So this is the Grafana UI. So before I go into Prometheus, I would first show you what are the default dashboards which are provided by that Prometheus stack. So here, if you look at whatever is under the Kubernetes or starts with Kubernetes, these are the default ones, dashboards provided by the Kube stack. So we have things like the compute resources for pods. These are named as Kubernetes mixins, or it has a tag as Kubernetes mixins. They have the resources like networking, namespaces, all these different kinds of cluster level information can be visualized very easily using different dashboards. So let's look at namespaces, for example, or networking, and we can see how much bytes are being received under Kube system. We can also see which are the different pods and what is the bandwidth for each of the pod that is taking. You can also see that there are different types of widgets which are available. So here we have like a steering wheel, then there is just a table below. All these can be modified. So these are just one way of creating a visualization, and all this data is coming from the Prometheus data that is stored. So I can edit this and I can change these colors, the way this widget is showing the data. So let's look at maybe one more, which has slightly more number of widgets. And let's go to pods, for example, compute resources. And here we can see the CPU utilization for different pods. So I have like the conference demo API is there. There are 3 instances of the API. There is a database deployment running. There is Elasticsearch masters running. And it is showing how each of those pods, they are taking the CPU resources. Across the cluster, because I have a 3-node cluster here, we can see what is the CPU utilization from the request. So I can set a request for the pods or resources, like how much CPU I need when scheduling the pod, and also the limits. So this gives us in very broad view or at a very high level, how the resources are utilized from the pod utilization point of view. So you can see that all this visually very intuitive kind of graphs, charts, and the data, it makes a lot of sense to build this kind of graphs for, let's say, business metrics or even for infrastructure metrics that we want to see. So we were looking at the Kubernetes related ones. Let's go and look at our application one. So for the Spring Boot, there is a dashboard created by, let me go into manage here. or browse. And if we can create folders. So I created a Spring Boot folder. There is a dashboard created by Istio for Prometheus from Prometheus data based on Spring Boot related different metrics that a Spring Boot application can produce. So here we can see different kinds of errors for input output, the duration, utilization, the JVM heap. Since this is a Java-based project, a lot of JVM metrics can be extracted, and also the log events. So let's see the change or real-time changes to this. So here we have the HTTP request statistics that is shown for average and max. So let me go and try to hit this API, the conference demo, and just move this. Okay, let me use tab. Okay. So here I will run a loop which will query the speaker's endpoint in that API. And next thing, this one will go for 2,500 times or something in that range. This one will be for the sessions API or sessions endpoint 1,500 times. So the speaker and the sessions are being requested continuously. And what I expect is this one is getting refreshed every few seconds, I think every 5 seconds. So we should see a change in these metrics, the average and the max for HTTP request. And we should also see these requests coming in or the rate of that request shown here. You can see speakers as being shown here. The API speaker call, and there is also the call for sessions. And we can see the average time and the max time has also starting to change. So this way, almost in near real time, we can see the impact of what the application is doing and how it is impacting different metrics for that particular application. So how do we do this in terms of setting which services have to be monitored by Prometheus? So after installing or after setting up these properties, there is also a minor change custom resource to be created for triggering or targeting our services. So in our conference API, we have an object which is created, which is of the type, not the rule. It's called a service monitor. So we have a service. The service is named as conference demo service. And for that, we are creating a service monitor. So this service monitor is the object, which is a custom object required by Prometheus. This tells Prometheus that you can look at an endpoint called actuator Prometheus, and there is a port called metrics port, which is defined as part of my service creation. When I create that service, I create a port in the Kubernetes service and name that port as metrics port. So these metrics for this particular service will be available, and Prometheus will be scraping those metrics. So instead of pushing the metrics to Prometheus, Prometheus uses the pull mechanism. And that is how it is able to pull the data from our Kubernetes cluster. I see a message that my time is up. Okay, so I can stop here. There is still the last part, which is log aggregation, not the log aggregation, event handling, but probably we can do that sometime later as part of your user group. So just give me a couple of minutes since we started about 5 minutes late. I will just quickly wind up with the resources section. Okay, so this is what we saw in terms of the Spring Boot and the Prometheus integration. I was supposed to talk about exception handling, but due to lack of time, let me skip this part. Let's go into the summary. So what we saw here was end-to-end integration from a observability and monitoring point of view. We used for the RabbitMQ and .NET as well as the Spring Boot-based applications, the FluentBit, Elasticsearch, Kibana for log aggregation. For monitoring, we use Prometheus, and I was supposed to show you Sentry, but that's for the next talk. Then in terms of the summary, we can use Elasticstack for centralized logging. Kibana can be used for visualizing those logs and building the dashboards. And for the monitoring part, Prometheus collects the metrics and Grafana is used for visualizing. So to help you with some of the resources, I've given the links to these projects like Elasticstack, Kibana, FluentBit. There are also some YouTube videos created by a guy called Hussein Dalai for the Prometheus and Grafana. You can refer to that. And the links for the GitHub repo is available on my GitHub. So I provided the links here for both the .NET as well as the Spring Boot application. And the slides are already published to SlideShare and SpeakerDeck. Thank you. Thanks for giving me this opportunity. And I hope to connect with you guys later. Thank you.
Once again, Nilesh, it was a very, very wonderful session. Thanks for such a beautiful presentation. And I hope to see you soon again in the next tech phase, which are tech talks, which we are planning in next 6 months. So I don't see any questions over here from any of the participants, right? So I think we can close this session over here. So if you have to say anything in closing comments, you have a couple of minutes before I summarize and close this session.
Oh, it's been a wonderful experience. Yesterday as well as today, I attended some of the talks today, and I found that this is really good, whatever you are doing as part of this event. So thank you. Thank you for giving me an opportunity to share some of these topics. And I hope the attendees would have benefited from whatever little bit I was able to share as part of these 2 talks.
Yeah, surely. I assure you that your presentations were good and attendees were definitely benefited. So thanks for all your efforts and all the presentations that you have made, and hope to see you soon in the next talk series. Thank you once again, and I would like to thank all the attendees of the session also. Bye for now and have a nice time.
Thank you.